Hi, everyone. Thank you for being here. My name is Rishi Singh. I am a research scientist at Clark CGA out of Worcester, Massachusetts. So happy to be in my home state of Massachusetts presenting today to all of you. So my talk is titled Ponds from Space, Monitoring Pantropical Aquaculture using Aquaculture and Coastal Habitats using satellite imagery with machine learning. So this project just gives an overview of the research. So this project has been going on since 2014, so over 10 years now. We've been working with the Gordon and Betty Moore Foundation as our partners, and what we've been doing with them is trying to use satellite imagery and geospatial technology to tackle questions around aquaculture and what impacts aquaculture has been having on coastal habitats and in particular mangrove forests. So if you look, if you look on the left side, you can see an example of one of these maps. So in the top right corner, you have a false color composite from a Landsat image. This is an area covering Guayaquil, Ecuador. And in the bottom right, you can see an example of one of these land cover maps we make with all the key classes. So mangrove, coastal wetland, aquaculture, water, other. And so basically what we do is we take the Landsat imagery, it's pan sharpened to 15 meter, and then we create these yearly land cover maps for the years of 1999, 2014, 2018, 2020, 2022, and 2024 for 17 countries. And then we take these maps and we make complementary reports and then also put them up on our online web portal, which you can see there. So this slide just shows you the mapping scale. So as you can see, we've been mapping 17 countries. It's over 600 quads. Currently, we're working on a phase 6 of the project where we're mapping 2024 in 5 of those countries. This slide just shows the research methodology kind of from a glance. So as you saw on the previous slide with all the tiling from the Landsat system, in the top right corner, you have an example of Thailand. So you can see the country of Thailand, and then over in blue is all the Landsat quads. And so basically what we do is we take the Landsat quads, and then at each individual quad level, you take the imagery, and then we will create a land cover map out of that, and then we mosaic them all back together, which you can see in the bottom left corner. And then those maps get fed into our online server where you can go interact with them, build maps of them, get statistics. This slide just goes over the classification technique as a whole. We can kind of go through this, but the long story short on this is that we have an automation server in the basement of our building. We go through a methodology we call the prior knowledge projection to create these maps that we can then use to help clean up manually. So that's a job that takes a lot of labor. And then this just shows the data products we've been able to make out of this. So we have our land cover maps, as I've mentioned. We also do change maps, and then we also do projects that utilize the data to do different types of modeling. So things like risk assessments, vulnerability maps, and we also have experimental things like deep learning chip libraries that we've been developing. This just shows an example of our interactive web map platform. You can see this in an area in Indonesia. It's a pretty staggering amount of deforestation in red. And then how does all this relate to OpenStreetMap? So like I mentioned, those maps can be used to do like risk and vulnerability mapping. In this example, you can see here, we've used the roads data from OpenStreetMaps to build out a model, basically where you can see the risk of the mangrove forests. And that's what I have, so any questions?